Hello everybody, it's time for our first flipped classroom lesson. This lesson is over Unit 1, Lessons 1 through 3 about matter. In this lesson, matter matters. Yeah, especially because you're made of matter. During this lesson, you are going to need to write down only the information that is bold and underlined. It's going to go into the blanks on your green study guides. You can write them down into your notes as they are presented. Remember, you can do this at your own pace. So if you need to speed it up or slow it down or pause, you have the ability to do that. So take your time and ask questions if you have them. First, we're going to do a 3-minute crash course in matter. Check out this awesome video clip from Crash Course Kids, and then we're going to write some stuff down.
Hey, what's matter? No, not what's the matter. Obviously, since you're here with me, you're pretty awesome at the moment. You might have heard that everything is made of matter, and that's true. You, soccer balls, iPads, even your pet Fluffy, all made of matter. So that's interesting. But what is matter exactly? The scientific answer is matter is anything that has weight and takes up space. You already know about weight, right? That's just how heavy something is. Like if you've ever been to a doctor's office, the first thing they do is have you stand on the scale so they can measure how much you weigh. As for taking up space, another way of thinking about it is that all matter has volume. It simply fills the area it's in. When you pour water into a glass, for example, the water's volume is the amount of space that it takes up in the glass. So all matter has volume and weight, but it sure doesn't all look the same. Well, that's because matter comes in different forms, or states. Liquids are a state of matter that I'm sure you're familiar with. If you've ever poured yourself a drink while trying to watch TV, you might have noticed that liquids take up space, because once the space inside your glass is full, right on the carpet. Sorry, Mom. You also know that water has weight if you carry a water bottle. As you drink from it, it gets lighter because you're removing water from it. Solids are matter too, of course, probably the most obvious kind. Rocks are solid, and so is ice, which is just solid water. Soccer balls are solid, iPads, your pet Fluffy, and every single guy in One Direction. And just like rocks, all those things have weight and take up space. Now, you know what's weird? Sometimes matter can't be seen or felt, but it's there. Like the air we breathe. Air is an example of gas, the third main state of matter. And I probably know what you're thinking. How do we know air, or any gas really, is there if we can't see it? Well, we can prove it by doing an experiment. Science. Let's start by asking the question, is air matter? Because if it is, it should take up space and have weight, right? To see if air takes up space, look it, I can easily drop an empty balloon into this little box, but a full one won't fit. That's because the air that fills the space inside the balloon is bigger than the space inside the box. Now, does air have weight? Let's try something else. Take 2 empty balloons and tape them to the ends of a meter stick. Then we'll hang the meter stick on a string so that it's perfectly balanced. Now let's see what happens if we blow up just one of the balloons and put it back on our meter stick. Check it out. The end with the full balloon sinks. It weighs more than the empty balloon because the air gives it extra weight. The balloon full of air will always weigh more than the empty one because air is matter and matter has weight and takes up space, whether it's a liquid, a solid, or a gas. So listen, the next time someone tells you that something doesn't matter, you can tell them to their face that technically everything is matter. And tell them Sabrina said so.
Okay, so let's recap everything from that video. What exactly is matter? Matter is made of atoms. As Sabrina said, matter is anything that has mass and takes up space, which means that it has volume. Everything from a soccer ball to your pet Fluffy, just like she said in the video. So anything that is a solid, a liquid, or a gas is made of matter. The smallest unit of any substance is called an atom. So let's look at those little molecules in the liquid. One of those is an atom. Atoms are constantly in motion. An element is a pure substance made of only one kind of atom. We know of 118 of these elements, and they're found on a table and organized called the periodic table. Here's what it looks like. You may have seen these hanging in your science rooms. You'll probably get a little bit more into this in 8th grade, but we're just going to talk about the basics. Some of these elements might be familiar to you. Things like gold, oxygen, like in the air that we breathe, aluminum, found in its natural form, and when we use it to make things like aluminum cans. Also, helium. Let's check out Jimmy Fallon's take on playing with helium. Do not try this at home.
It's helium! It's helium, Morgan. It is helium.
It's very undignified.
No. I think your voice sounds great. It's not undignified.
Some people just have voices like this, so you're actually making fun of those people. See?
All right, that was pretty good. Okay, so as we have already learned, an element is made of only one kind of atom. However, most of the time, atoms like to bond. That means they like to join together with other atoms to make larger units called molecules. So as you can see in this diagram below, here these are going to be your elements. They're going to bond together to make molecules. And when molecules all bond together, they make larger things. So this is, for example, how we get water. So we have hydrogen and oxygen that bond together, and when lots of molecules of water bond together, you get a droplet of water. All right, so as you saw in the video earlier, there are actually 4 states of matter. The video only went over 3, but there's actually 4. So let's talk about each of those states. Matter exists in 4 states. They are solid, liquid, gas, and plasma. Solids have a definite shape and volume. Water is a solid when it is in the form of ice, like you see in the picture. In the box on your notes, draw this picture, the one in the green box. Notice how close and how structured the molecules are together in ice. This is how molecules are held together in a solid. Next is a liquid. The substance has a definite volume, but not a definite shape. Think about water as a liquid. The molecules are close together, but they can still move freely. So let's say you have 50 milliliters of water and you spill it on the floor. Well, it's still 50 milliliters of water. It still has a definite volume, but now it has a totally different shape because it's all over your floor. Now in that box, go ahead and draw how close the molecules are in the liquid. The next state of matter is a gas. Whenever you breathe out on a cold day, that's water vapor you're seeing come out. Gas has no definite shape or definite volume. So think about water vapor like in the picture. The molecules move freely. So now draw in the box how close the molecules are in the gas. The last state of matter is called plasma. This is a relatively new development, just that has happened in the past couple decades. Plasma is a special state of superheated gas. We see this when we see lightning. Changes of state. So what happens? Why do we have water that goes from a solid to a liquid, or from a liquid to a gas, or even back again? Well, in solids, atoms and molecules vibrate in fixed positions. Remember we talked about at the beginning that molecules are always in motion. When energy is added to these molecules, they vibrate faster and they shake apart, and they move freely, changing it from a solid to a liquid. Think about a piece of a delicious Hershey's candy bar, and it's sitting in your hand. It's not going to stay a solid bar of chocolate forever when you hold it in your hand. As energy is added to the chocolate, it starts to melt in your hand and it's changed from a solid to a liquid. Adding even more energy makes these molecules move faster, having the liquid change into a gas. Look at this picture of boiling water. As even more energy is added to that water, it's changing from a liquid to a gas, and you can see the water vapor coming out of the pot. So what is it that makes this energy? Well, usually a change of state is caused by adding or take away energy in the form of heat. That's why the candy bar melts and the water boils. It's because of the addition of heat. The temperatures at which matter changes varies from substance to substance, but all have two fixed temperatures at which they change state. Every substance has a melting point. That is when it goes from a solid to a liquid. Water does this at 32 degrees Fahrenheit, which is 0 degrees Celsius. So that's when ice will start to melt. All substances also have a boiling point. This is when a substance changes from a liquid into a gas. Water does this at 212 degrees Fahrenheit, which is the same as 100 degrees Celsius. See, I told you that metric stuff was so much easier. However, some substances can go straight from a solid to a gas and skip the whole liquid component. This is dry ice, which is solid carbon dioxide. Some of you may have seen dry ice before. This process of going straight from a solid into a gas is called sublimation. So are you still watching? If you are, congratulations. You get to check out this dry ice experiment fail. Do not try this at home. All right, folks, that's all for me. Thank you for watching. Make sure you finish filling out your green study guides.